Welcome back to Cryptography and Network Security series. In this video, we'll be discussing about substitution cipher. We'll also look into Caesar cipher and monoalphabetic cipher in detail. So let's start by understanding what substitution cipher is. So two methods or two operations which could be used to convert the plain text to cipher text or perform the encryption operation. First one is called substitution and the second one is called transposition. Substitution means you are substituting a particular alphabet by some other alphabet or number or any symbol. Whereas transposition means you are just rearranging, that is shuffling the values here. So in this video, we'll be speaking about substitution. So substitution cipher, letters of plain text are replaced by other letters, numbers or symbols. Substitution involves replacing the plain text. Plain text would be sequence of bits, bit patterns with cipher text bit patterns. So again, we have different types of substitution ciphers here. So with each these cipher, no, there will be a fixed rule as to how the encryption process or the decryption process is proceeding. So first one we have is Caesar cipher, then we have monoalphabetic cipher, Playfair cipher, Hill cipher, and we have polyalphabetic cipher and one-time pad. Speaking in general, substitution ciphers are relatively easy to implement, but they are not that secure. So we can say that they are the building blocks for more complex ciphers. So frequency analysis is a common technique which is used to break any simple substitution cipher. So firstly, we'll speak about Caesar cipher now. So here we have Caesar cipher, the earliest known, simple and used by Julius Caesar. So Caesar cipher is one of the most used, or let's say one of the simplest and oldest known substitution cipher, which is also used by Julius Caesar. So this basically involves replacing each letter of alphabet with letter standing three places further down to the alphabet. So we'll understand this with an example here. So here we have written down all the alphabets right from A to Z, and for each alphabet we have given a numeric representation. For A it is 0, for B it is 1, and so on till for Z it is 25. So as and when you are solving any problem for ciphers, no, so make sure you write this table. It becomes very easy for you to move further. So here we have the plain text, that is Bangalore, Bangalore. So we have to find the cipher text for it. So for B, tell me what is the equivalent 1. So 1 plus 3, I'll get 4. 4. 4 equivalent is E. So for in place of B, I can write E as the cipher text. Next, for A value is 0. 0 plus 3 is 3. So 3 I have D. So in position of A, I have to write D. In position of A, I have written D. In position of B, I have written E. For N is equal to 13. 13 plus 3, 16. What is 16? In place of N, I can write Q. Next, for G is here. G plus 3. 6 plus 3, 9. I get J. I have written J here. A is here. Or I can just easily shift here. 1, 2, and third. Third is D. D is I have written. For L is here. 1, 2, and third is O. So I have written O. For O now. 1, 2, third is R. So I have written R here. Next R. R is here. 1, 2, and third I have U. So I have written U. Next E. E is here. 1, 2. Next third I have H. H I have written here. So this is the cipher text. So this was about the general shifting using three positions in the table. Now if I have reached Z, so if Z is there in the end, so let me consider a word 0. If I have to write cipher text for this plain text, how will I do it using Caesar cipher? So from Z, if I shift three positions, I get 25 plus 3, 26, 27, 28. Is 28 there here? No. In this case, I have to wrap around. So it will again start from A. After Z, it will start from A. So 1, 2, and third one would be C. So for Z, the equivalent is C. For E is here 1, 2, and third is H. So for R, first position, second position, third position is U. For O, first position, second position, third position is R. CHUR is what I obtain as the cipher text for this particular plain text. So this is what I've written down here. In case of Z, the alphabets will wrap around. So I hope you have understood these two points. But broadly speaking, these two are in general case you are explaining. But for solving complex problems or for deducing the ciphers for long texts, you cannot keep on counting like this. No, if k value is 32, can you keep on counting 32 times like this? No, it is not possible. In that case, we have to deduce a particular formula or formulae, set of formulae. So that's what we have written. For the process of encryption and decryption, we make use of modulo arithmetic. Each letter in the plain text can be shifted by adding a fixed number to its position and taking the rest modulo 26. So for encryption, after encryption, what should we get? Cipher text. So C is equal to cipher text, which is equal to encryption function, which includes K, that is the key or the shift value, and P is the plain text. K will tell how many positions to shift. Usually in case of Caesar cipher, K value is 3. Okay, so we get in order to get the cipher text, the formula is P plus K mod 26. And for decryption, it is reverse. So we have to get the plain text, which is equal to decryption function comprising of key and cipher, which is equal to cipher text minus key minus mod 26. So we'll understand these two when we are actually solving the problem. Okay, so let's look into the example. Use shift of 5 right to encrypt the message and write the final code in 4-letter blocks. So here we have the plain text, that is meet at the bank at 8 a.m. So this is the plain text which I have. We have to write the cipher text for this. What is the cipher text? We have to find out using Caesar cipher. So let me write down the formula here. I am performing encryption using Caesar cipher with k value or the key value as 5. That is, I'll be shifting 5 times. So the formula is C is equal to E of k comma P, which is equal to P plus K mod 26. So this is the formula. Let me start writing for each and every alphabet. I'll start from M, then I'll go to E, E, T, A, T, and so on. So let's start from M first. M, E, T, A, and so on. So for M, if I write C, the cipher text would be encryption of K. K is 5, K value is 5, and plain text. M equivalent, what is the M equivalent? M equivalent I have as 12, right? So I write 12 here, which is equal to P plus K mod 26. That is 12 plus 5 mod 26. 12 plus 5 is 17. 17 mod 26 is 17 itself. So in order to perform the modulo operation, just remember on this side, if x mod 26, if you have to find the answer, if x is less than 26, then this answer y is equal to x. Or let me write it down properly in a proper formula. So x mod 26 is equal to x when x is less than 26. If x mod 26 is equal to x minus 26 when x is greater than 26. So just remember this formula, it will be easy for you to understand. We'll actually use this formula in the upcoming problems. You'll have a better clarity. Okay, so let me erase this down and start solving. So 17 is the number which I have obtained. 17 equivalent, what is the 17 equivalent? I have R here, right? So 17 equivalent is R. So for M, I'll write R as the cipher text. So let's write for E now. So for E, the cipher text would be equal to encryption function 5 comma E equivalent is 4. So 5 comma 4 is equal to 12 here, P plus K. That is 4 plus 5 is 9 mod 26. 9 is less than 26, so 9 is the answer. And 9 equivalent is J. So I write J here. Again E is there, so again J. Now for T, cipher text E of 5 comma T equivalent is 19. So here it would be equal to 19 plus 5 is 24 mod 26. 24 is less than 26, so 24 is the answer. 24 equivalent is Y, so I write Y here as the answer. Now for A, E of 5 comma 0. So 5 plus 0 is 5 mod 26. A value, 5 value is F. So here I write F. And for T, again I have Y. And for T, again I have Y. And this is how I can fill the value for rest of the alphabets. So here I can write one statement. Similarly, we do for rest of the plain text and obtain the cipher text. Let me write down the cipher text. R J J Y F Y Y M J F F Y J N L M Y F R A A. So this is the final cipher text which I have obtained. Now they have told me to club in 4-letter blocks. 4-letter blocks clubbing means write these four ones, beside that these four, then these four, then these four, then these four. Yeah, this is extra, so write it again, write it beside, that's it. So this is how we obtain the ciphertext. Once you obtain the ciphertext, you have done with the encryption process. Now you have to do the decryption process. So let us perform decryption. So let me write the decryption formula. P is equal to D of K comma C, that is equal to C comma C minus K mod 26. So let us take the first part, R J J Y F. I'll write for the first five. Okay. So I write R. For R, let me write plain text is equal to decryption of K is 5 comma C. Number equivalent of R is 17. So I'll get 17 minus 5 mod 26, that is 12. 12 equivalent is M. So for R, I have got M. Now for J, let me write P is equal to decryption of 5 comma J. So it is 9 minus 5 mod 26, that is 4. 4 equivalent is E. So for J I got EE. Now let me write for Y. Plain text is equal to decryption function including 5 and Y equivalent is 24. So it will be 24 minus 5 and here mod 26. So I get 19. 19 equivalent is T. So I have got meet. And let me write for F also. P is equal to decryption of 5 comma F equivalent is 5. So here 5 minus 5 mod 26, that is 0 mod 26. I get 0, that is A. So I have got A here. Again Y means T, again T here, and so on. So I can write the plain text which I can obtain, which I get back is meet at the bank at 8 a.m. So this is the plain text which I have obtained back. So this is how we actually solve any of the problem given. So firstly you write the encryption part. Once you deduce the ciphertext, you should also write the decryption part and mention the plain text. That's when your problem is, or the solution which you have written is complete for that particular problem. Going on further, let's look into the brute force cryptanalysis. So for any ciphertext or any cipher which you are considering, you should also look into it from the attacker's perspective. You should understand, is it easy for the attacker to decode the algorithm or decode the ciphertext, or is it difficult for him, or how does it, what strength does it hold? So all these things need to be checked. So let's look into these one by one. So brute force cryptanalysis. If attacker knows that I'm using Caesar cipher and the ciphertext is known, then brute force attack is very simple, as there are only 25 alphabets. To decrypt, attacker can start key value from 1 and possibly get the answer in middle process. Suppose if I have taken apple and if I take key value as 1, then I'll get B, P, Q, Q, L, M, E and F. If I take key value as 2, then I'll get C, R and so on. So that's how it is. So if I write A, P, P, and on the other hand if I write C, R, it is very easily understood that K value is 2, right? So if he knows what is the ciphertext, then it is very easy to find out the value of key, because by performing permutations, because there are only 25 alphabets, the attacker will keep on checking. It will start from key value as 1 and it will keep on checking till 25, and out of these there is one possibility that whatever answer you have got is the cipher text. So that's how we can say that Caesar cipher is very vulnerable. It is very easy to break from the attacker's perspective. So here we have three characteristics which enable brute force cryptanalysis. So the first one is known algorithm. Because the Caesar cipher algorithm is well known, attacker will understand how it transforms the plain text. Then we have limited key range, 1 to 25. Only 25 possible keys are there, very easy to understand. Then we have recognizable plain text language. If I write APPL, it is obviously understood that E should come here. If I write M dash ANG, okay, M dash NGO, then it is already understood that A has to come here. Because we are making use of recognizable plain text language, it is easy to decrypt. So that's what are the three characteristics. Looking at the limitations now. So the first limitation, we know the key space is very small, and second limitation is if the language is known, it is very easily understood by the opposite person. So we how to overcome this? We can make use of the complex algorithms like DES, or we can compress the plain text or the cipher text. When we are compressing the plain text or making use of unknown language or creating a different language, then it can be little difficult for the attacker, but over a long period, it becomes very easy for him or her to decrypt it. So this was about the limitations. Let's look into this question. Again, let's solve this quickly. So we have welcome back. So let me write encryption using Caesar cipher. So this is the plain text which they have given, and key value is 6. Okay, they have also given us the key value. Now let me start from W, E, L, C. I'll write for these four and I'll conclude it. Okay, so let me write down the formula. C is equal to P plus K mod 26. So P value is unknown, K value is 6. So W, for W the number is 22. 22 plus 6 mod 26. So here we have 28 mod 26. So 28 is greater than 26. So subtract it. 28 minus 26, I get 2. So 2 is C here. E equivalent is 4. 4 plus 6, that is 10. 10 mod 26 is 10 itself. 10 equivalent is K. So for E, I can write K. For L, L is 11 here. 11 plus 6 mod 26. So it is 17. Mod 26 is 17, and 17 is R. So I can write R here. For C, C equivalent is 2. 2 plus 6, 8. 8 mod 26 is 8 itself. 8 equivalent is I. And so on. Similarly, for all alphabets, we can obtain the cipher text. So ultimately, the cipher text obtained would be C, K, R, I, U, S, K, H, G, I, Q. They have told pair of three outputs. So these three, then these three, then these three, then these two. That's how you have to write the output. So here we are done with the encryption process. Now let's look into the decryption process. So decryption using Caesar cipher. So let me write down the formula. P is equal to C minus K mod 26. So yes, so let me start from C, K, R, and let me write for these four. For CP is equal to 2 minus 6 mod 26, which is equal to minus 4 mod 26, and we get minus 4 here. But there's minus 4 there here. So if we consider from this side, so this is minus 1, minus 2, minus 3, and minus 4. It is W. We get W back. So W I have written. For K, P is equal to K equivalent is 10. So 10 minus 6 mod 26. 10 minus 6 mod 26 is 4. 4 mod 26 is 4, and 4 value is E. So I have written E. For R, R equivalent is 17. 17 minus 6 mod 26, that is 11 mod 26, and 11 mod 26 we have L. So I'll write L here. For I it will be C, and so on. So similarly, we can write it as we will get back the plain text as welcome back. So this is the solution. So here initially we took the plain text, converted it into ciphertext. From ciphertext we got back the plain text. So for every question which you are solving in the exam or in general, make sure that you write the encryption and the decryption properly. That's how you can draw to a conclusion. Okay. Next cipher which we have is monoalphabetic cipher. So we know that Caesar cipher has only 25 possible keys, which is very easy to break. We have seen how. So by making use of arbitrary substitutions, each letter in the plain text alphabet is mapped uniquely to a ciphertext alphabet, resulting in 26 factorial possible permutations. So with over 4 into 10 to the power 26, this method expands the key space. Compared to the Caesar cipher, this has a upper hand because it will expand the key space to 4 into 10 to the power 26 keys. So in this condition, it will be a little difficult for the attacker to decrypt or understand the key. So over frequency analysis by attacker, as monoalphabetic cipher retains the letter frequencies of English alphabets like P, Z and E, most commonly used or highest frequencies, it helps the attacker to decrypt over time. So suppose if I write any alphabet for that matter, telephone, you can see that E has been repeated 3 times. In general also, if you consider the English alphabets, there was a study conducted in which P, Z and E were having highest frequencies. So this will again help the attacker to decode whatever the key is. So in order to avoid such situations, so we'll have to make use of these by using high frequency diagrams. So by making use of high frequency diagrams, we can or diagrams or trigrams, we can retain the certain key level letter mappings, accelerating the decryption process. So it could be like you can make the language irregularities. So the countermeasures include homophones. Homophones means we have to assign multiple cipher symbols to frequent letters like E to take away from the single letter frequency patterns. Then we have encrypting multiple letters. So some ciphers encrypt block of letters together to hide a single letter and diagram frequency information. Then we have multiple cipher alphabets. That is, each and every time when the alphabet is repeating, give a different meaning to it or allot a different cipher to it. So let's look into this example now. So this example is pretty easy to understand. Monoalphabetic cipher are very easy. There's nothing much in it. So here we have the example, that is plain text is given here. And this is how the mapping is done for each alphabet. So this mapping would be available by the sender, and the receiver will also have this. That's how they'll be able to deduce the ciphertext and the conversion back to plain text, right? So for A, the mapping is K, equivalent is K. So I'll write K. For P, it is L. For R, it is N. For I, it is T. For C, it is J. For O, it is W. For T, it is Q. So this is the ciphertext. Now tell me, is it possible for the attacker to understand this? Only if he has the idea about this particular mapping, he'll be able to decrypt this. But then there could be chances that certain alphabets are being repeated. So understanding this pattern, he or she may be thereby able to deduce the key or try to deduce the key. Again, this is not the best algorithm or the safest algorithm. So this is the ciphertext. From ciphertext, if I have to return back or write back the plain text, let us see how it is done. So I have K here. So whenever K is obtained, whenever K is obtained on this side, what is the possible alphabet above it? A, right? So I'll write A. For L, so if L is here, what is the possible alphabet? P. I'll write P. Similarly, for N it is R, for T it is I, for J it is C, for O it is W, and for C it is O, and for Q it is T. I get back the apricot as the plain text. So this was about the monoalphabetic cipher. It is very simple to understand, and just one simple example is sufficient enough. So I hope you have understood how Caesar cipher works. We have solved two problems which have been appeared in the previous year papers, and they were asked in internals also. So make sure you don't miss out such problems. And if you have any doubts, do let me know in the comments. And stay tuned In the next video, we'll be discussing in detail about Playfair cipher, which is a very important one. If you have any doubts, do let me know. Thank you.